Let's see how to code an AI bot using Python that will play the GeoGuessr game. So it will take the images of the game and it will automatically click to the map location to play every turn. So it will be an autonomous bot that will be playing automatically to GeoGuessr, and we'll be using LangChain in this project to integrate OpenAI but also Gemini and Claude 3.5 from Anthropic. So we'll be integrating the best and most popular models out there, the Vision LLMs, that can take images and prompt instructions to predict any task like this one of playing automatically to the GeoGuessr game. We created a similar video some months ago, you can check it if you haven't seen it yet. That is a poker bot that automatically plays to poker, taking screenshot images of the poker game and automatically playing the decisions that it takes. Make sure to check that video from the channel if you are interested in poker and you haven't seen it yet. So let's see how to code the GeoGuessr AI bot. You'll find the code and the blog of this video in the description, so you will be able to follow better the code and copy and paste it if you need. And this is the workflow of today's logic. So we'll be using Python for all of it, and we'll define a prompt instructions and we'll take with pyautogui automatically a screenshot of the game. So we'll pass this prompt and this image to this model. We'll use LangChain to make it work easily across all the models. So with the same code, it will work with any of the most popular models, and the model will return us a response. And if we define properly the prompt instructions, the LLM will make some reasoning to be more accurate, but in the end we'll return the latitude and longitude of this predicted location. Then we'll define here the most complex part of our project, that will be this function of here that takes a latitude and longitude as input, and it outputs the x and y coordinates position of our map in our screen, where the bot will automatically click. So we will not do anything, the bot automatically will predict and click into that map region, and then it will repeat to the next turn. So it will click the guess button and it will go again to the next turn. And in order to do this, we'll need to calibrate. We'll see now how to do it, but we'll need to calibrate our screen. So we'll need to tell our code where is the top left and bottom right of the game, and also we'll need to tell where are two known locations. We'll use Kodiak, that is this island of here in bottom of Alaska, and also Hobart, that is one location here in Tasmania, here in the south of Australia. So we'll use these two known places that we know their latitude and longitude, but also we'll tell where are in our minimap screen the x and y coordinates of it, to then build this function that will use these known locations to transform any predicted latitude and longitude from the model to the x and y coordinates in our screen, so our bot can click into it. And this is more or less the overview of today. And let's see now one important thing that maybe you were guessing, if it's possible to use AI assistants or any kind of bots in GeoGuessr. So it's allowed, but only if you are playing by yourself. So you cannot use any assistants if you are in a game that has leaderboards, public leaderboards at least, or trophies, or a competitive mode. You cannot use these AI assistants or any kind of assistants to play unfairly against other players, so make sure you don't cheat. So we'll be using this logic today in private parties or in single modes where there are no leaderboards, like classic maps for example. So make sure to do the same, and if you try this code, don't use it unfairly against other players. This is only an experiment to see how to build a random bot for this case. So if you learn how to code this bot, you will know also how to build similar bots for other different and useful tasks. Okay, so let's go now to VS Code, and you need to create a folder for the project. So I call my folder GeoGuessr AI Bot, and here we will start by opening the terminal, and you need Python install. Okay, I have the 3.11 version. Probably the 3.13 version that was just released a week ago, probably it won't work because it's too new and not all libraries are yet ported to it. And here we will need to put python-m-vmb. So we'll create a virtual environment, and we have it here already created. So now we activate it like this, bems scripts activate. Let's make this screen larger for now. And now we can install all the needed libraries that are all of those here, but you'll find this code in the description, so in the blog and the GitHub repository, so don't worry, you can copy it from there. Let's install them. Okay, it can take a while, but now we already have our library installed. The next thing will be to have here the .env file, and here we will be putting our API keys for the models that we want to use. So today we'll see how to use the OpenAI GPT-4o. Here you can put your API key if you have it, or also Anthropic Claude 3.5 and Gemini 1.5 Pro. But if you don't have any of those API keys, don't worry, you can use only one or two of them. You don't need the three of them if you don't want. And if you don't have any of them, you can find the OpenAI one in platform.openai.com. The Anthropic one is in console.anthropic.com. And the Google one is in Vertex AI in Google Cloud, if I'm not wrong. So you can find how to create any of those API keys searching in Google for them. But make sure that you have the API key with some credits loaded. So make sure you don't share your API keys. And now I will put here my real ones. And now that we have the .env file created with our API keys, let's create the .gitignore just in case we upload this code into GitHub. So here we have to put the virtual environment, also the .env, so we are not sharing the API keys with everyone. And finally the PyCache folder. Okay, these three of here, and we can close and save this. Now let's create a new file. It will be called selectregions.py. And here we'll be creating these helper functions that will allow us to calibrate the X and Y coordinates of the pixels in our screen. So we will import here these libraries, and we'll need to define this list of here, so the regions that we want to select, also these map regions for every player, and finally this next round button. So these are the regions that we need. And here in this list of chords, we'll be placing every coordinate for every one of these regions, so the X and Y coordinate, and we'll be pressing the letter A from the keyboard every time that we have this region in our mouse. Then we will define this function that will be used by PyInput, and whenever we press the letter A in this case, it will go and will check what is the X and Y coordinates in our screen with pyautogui, and it will be appending it in coordinates and printing it in the screen. And then we will have here this other function, the getCoordinates function, that will go for every one of these regions that we define here, and then for every one of these map regions for every player. Now we will see only how to do one player, but this can be used also for having multiple players in the screen, and every player can have a different model. So every player is a bot, and we can put here OpenAI against the Gemini and also against Claude. So we can have 2-3 players with different models and see which model wins the game. And finally, the next round button. So for everyone, it will go and use the keyboard listener to use the onPress function and record these coordinates in this list. We'll see now how to do it. And finally, we will put together the regions list and the coordinates in a dictionary. And we'll create this YAML file, this screen regions YAML, where we'll be placing these recorded coordinates. And in order to run this, we need to define this. Players is 1 for now. So if name is main, if we are running in the terminal this selectregion.py, it will be running the getCoord. So let's make this small. Okay, so let's try this selectregions.py file to calibrate our screen, and we'll need to go to geoguessr.com, and it's necessary to have an account with a paid subscription, okay, because otherwise you cannot play if you are not invited in a party. So I paid for a single month to do this demonstration, and now I will go to classic maps, and here we will be playing today in the NMPZ mode, so we cannot move and we cannot even rotate, so we will have a single image to predict where is that place. And let's put it here to play. So we need to see this example place, and also we cannot move our screen because now we will be calibrating what are the pixel coordinates of every part that we defined before. So here in the terminal, let's activate again the virtual environment, scripts activate, and now Python select regions.py. We are running now the script that we just defined, and it is asking us the screen top left. So the screen top left is here in the GeoGuessr game, so the top left part. Now it asks for the bottom right, and you see here that you have here the X and Y coordinates. I have a 2K screen and you don't see the entire of it. It's only a small part that you see. But this is the X coordinates and the Y coordinate for me. X goes from left to right and Y goes from top to bottom. Now it asks for the bottom right. So the bottom right is here. Okay, let's move me. So the bottom right is here, the bottom corner of the game, here in the right. Now it asks for the map top left, and here you have to make sure that you see the entire of the map and you don't move it, okay? Very important, you cannot move the map or zoom it. You have to have it like this, so zoom out as much as possible and make the map as large as possible first, but then don't move it again. And here when you see the entire world, let's say, you have to select the top left here, that was the top left, and the bottom right again of the minimap. Okay, now it says to select the confirm button, and the confirm button is this bottom of here, but you have to select it in the right of it. So around here, let's press A to select it. Move the mouse to Kodiak. Kodiak is this island of here in the south of Alaska. I will show you now better where it is, but it's around here, this small island of here. And Hobart is here in Tasmania, in the south of Australia, and it's around here. Press A, okay. And finally, it asks to select the next round button. So we have to select now any region with the mouse, in this case, not with the letter A, and guess. So it doesn't matter because we want now to see this button of here, the next round. So we have to place the mouse here and press A now again, because this is where it's placed the next round button. Okay, so now that we see this map, let's see better where is Hobart and Kodiak. So Kodiak is this island of here in Alaska. So this is the island of Kodiak, and Kodiak exactly is here in the east of it. We were calculating before the minimap, but now you see here better where is Kodiak. So here, And Hobart, the other place that we are using to calibrate our minimap, is in Tasmania here, in the southeast of the island of Tasmania. So you have to place here when you're calibrating, okay, I already did it. I cannot move now the map because it's already calibrated, but you have to place here in Kodiak the mouse and here in Hobart, in this part of here that we saw before better. You can search them in Google Maps as well if you are not sure where they are. I will put me again here. Here in our project, we have here the screen regions.yaml that this script created. And if we check it, we see that for every region, we have the X and Y coordinates. So this works nice. Now let's close it and let's create another file. It will be called GeoGuessr And here we'll be defining the core logic of our bot. So we'll start by importing all of these libraries of here. Okay, we already installed them before. Also loading the .env. And we'll define now here the program instructions that, yeah, this worked for me, but you can improve it iteration by iteration. But in summary, we are telling here the LLM to try to predict where the image was taken, describe the relevant details, then list some regions and places where this could be, okay? So we'll try that the LLM does some reasoning before predicting where the place is it. And finally, to choose what is the most likely place and to tell the latitude and longitude of this place, because the LLMs like GPT-4o knows pretty much all the locations of the most popular places or regions at least. And finally, use this format and not add anything else, and use this lat and a float and longitude and float. So we'll be automatically parsing with code this location to later transform it to X and Y pixel coordinates. We'll see how to do this. Now let's define the class GeoBot, and it will have this program instruction class attribute, and we'll define here the init. So whenever we create a bot, we'll be passing here the screen regions, also the player number, then the model provider, OpenAI, that we bring from here from LangChain, and the model name GPT-4o. So if we want to use Anthropic, we have to put here chat Anthropic imported from LangChain Anthropic, and the model name that will be Claude 3.5 Pro, but make sure that it's correct, the name. Here we start defining the instance attributes, so the player, the screen region. So here we pass the dictionary of the screen regions from the YAML file, and we extract from this screen regions dictionary all the regions that we need to have. So a screen X and a screen Y, that are the X and Y coordinates from the screen top left. Then the width and height. If you remember that we told before that pyautogui needs the top X and Y and then the width and the height of the region. So we calculate them like this, subtracting from the bottom right X, the screen X, and doing this subtraction we get the width and the same for height, and like this we get the screen X, Y, width and height to have this region. We do the same for the minimap in this part of here. Then we put here the next round button coordinates, the confirm button coordinates, then here Kodiak X, Kodiak Y, and same for Hobart, and then the Kodiak latitude and longitude, and the same for Hobart, because then in the logic later we'll use them to calibrate our map. And finally here the model, that we instantiate the model with the model name. As we use LangChain, it's very easy to do this with either Anthropic, OpenAI or Google, because using LangChain the same code will work for all of them. So now before going forward here, let's create a notebook, dev GeoGuessr bot IPy notebook. And in this notebook we can see better what we are doing in every step. Here you have to put the virtual environment, okay? And here let's import all of these libraries. I'm not sure if we will use all, but let's run this. And we can try now to import here, import YAML. And we can load here this screen regions.yaml that we have here that we created before when we calibrated our screen regions. So let's run this, and okay, we see that it loaded this screen regions YAML file. And we can see here that for every region, it has the X and Y coordinates in a list. So it properly took all of those. Now in this next cell, we can import our GeoGuessr bot from GeoGuessr bot import GeoBot. And we can instantiate one GeoBot like this, calling it bot. And it's only necessary to pass here the screen regions dictionary like this. And if we run this, we see that the bot screen XYWH is coordinates of our screen game. So now if I do this smaller to see again the game, let's create here a new cell, and here we will try to see this screenshot. So we'll use pyautogui to take a screenshot of this region of here, this that we see here. And with Matplotlib, we'll print and see this screenshot of here. Okay, so we see it here, and apparently it looks good. So the pixel coordinates of our screen seems to be okay, and we can do screenshots. So in our logic, we'll take these screenshots and passing them to the model. Okay, now let's check the minimap. And for the minimap, we'll do something similar. So here in a new cell, we will do minimap with the screenshot of the bot minimap XYWH, and we will try to plot the minimap. Let's run it to see now, and let's pin the minimap for now only, because otherwise we won't see the minimap. And now we see that it's plotting the minimap region. So the top left coordinate and the bottom right coordinate are okay, because we see here the full minimap. But also the Hobart and Kodiak, we see that these red dots that we define here and here are properly in Kodiak and in Hobart. So we know now that it's properly calibrated because the red dots are in Hobart and Kodiak. So we know that it's looking good. Now let's continue developing the bot. So here we see that more or less what we are doing with all of these coordinates. So they are used to select the regions of the screen. Now here we'll define this static method that will be a function that transforms from PIL to base64. So the images that we take with pyautogui are PIL based, so the PIL library from Python, and we need to transform them to base64, encode them in this format. So the image will be in this string, and we can append it in the conversation and send it to the model. So let's see now how to create the message to send this to the model. And this will be another method, but this will be a class method. And we have to create a message, and it's a class method because the param instructions is a class attribute. So you can do this in other ways, but I found this more convenient. And here we will have the images data as a list. For now, every call to every model will be a single image. So this list will have only a single image in base64. But if you want to do something more advanced, you can put here multiple images from the same place. So you could rotate the image or navigate to have more images of the same place. And with more images, the bot probably would work better. But for now, we will only use a single one. And here we use the LangChain human message to create a content that is the prompt instructions text and also the image URL, encoding the image data with base64. And if we have here multiple images, so images data is a list as I mentioned, but if this has multiple images, not a single one, it will be appending here every image, but for now it will be only a single prompt instruction and a single image. And this will return this message to be sent to the LLM later. So this next method of here, it's called extract location from message. And this function will receive the response of the model. So this will be an AI message from the model and the content will be the text of it. So we'll be splitting it for every new line and we'll be trying to find if there is the latitude and longitude in it. Otherwise, we'll be popping the last line if it's not in there. And at the end, if there is some response, so if we find latitude in it, we'll tell that the prediction is that line, and otherwise we'll return none because sometimes the model won't exactly do what we ask, so it won't return this latitude and longitude. Sometimes it can happen, and if we return none, we can make it to predict again because most of the time this works. So this is only for the few cases that it can fail. And here, if it works and the latitude and longitude should be a line like this, like latitude being something like this and comma and longitude something like this. So if that's the case and it works, like this, we are parsing the prediction line split by the comma, getting the first part, splitting them in the colon, this one of here, and getting this part of here, trying to convert it as a float, okay? A little bit complex, but the idea here is to get this part of here as a float, because before it's a string, and this part of here as another float for longitude. So latitude and longitude as a float. Many of these steps could fail. So with this try block of here, we will return none if this fails, and we can make it again because most of the times this works. Then we pass this x and y, so this latitude and longitude, to this function of here that we'll define here. But basically this function is what it converts from latitude and longitude to our x and y pixel coordinates of the screen using the region coordinates that we defined before. And if it happens that for any reason the x and y coordinates are outside of the map limit, so if it's outside the x limit or the y limit, we will make x or y equal to that limit. So we want to allow the bot to click outside the minimap region. So we make sure that this doesn't break as well. And we will return x and y in the end if this works. So x and y should be integers of the coordinates. So in summary, this method is pretty important and it takes the response of the model and it returns where the bot has to click. So yeah, pretty much of the core logic is in here. And now let's define this lat.long to Mercator map pixels function, this method in here. And first we need to define this lat to Mercator y, and Mercator is this format. Okay, I will leave a link in Wikipedia explanation of it. So basically this map of here is in the Mercator format, and this is nice because some regions in the poles are better seen, but what it does, it expands in the y-axis. The closer you are in the poles, the more that it's expanded. So it's not linear to correlate any position in the y-axis, and for this reason we need this formula to transform from the latitude to the I coordinates in the minimap of the screen here. So we will need this Mercator y method to use it in here. And in this lat.long to Mercator map pixels, this method that we were using here, this receives the latitude and longitude, and it returns a tuple with the x and y pixel coordinates as integers. So we need to start defining here the Kodiak long minus the Hobart long, okay, the difference between our known positions, and then the difference between our desired position. So we'll take this relative difference between the known positions and our desired position to then here calculate what is the x-coordinate in the screen of this position with this formula here, okay? It's a little bit complex, but you can copy and paste this and it will work. And then do a similar thing for the y-axis, and we'll need to transform first to Mercator y and Mercator y2 for Kodiak and Hobart. Then the Mercator y will be the latitude, our input latitude of here, and then do something similar, so the relative difference of Kodiak and Hobart, and the difference between Kodiak and our desired position. And then we'll have the y with this formula here, and we will return as integers this x and y that we calculated in here. Okay, this is a little bit complex, but you can draw it and you understand better, so I try to draw it in here. So if we have Kodiak here that we know the latitude and longitude and x and y, and Hobart in here, so we know that in our screen, this is their positions, and we know the latitude and longitude of our predicted position. We can use this relative difference to know the x and y coordinates, basically. Okay, now we need two more methods, and we are done with our GeoBot class method, and the next one will be the method that will be clicking in our screen. So we'll use pyautogui in this select map location, and it will take x and y, and it will click into them. But as we are not pinning the map to see better the game, we have to hover over the map first, and then we click in the x and y position. We plot it if we optionally want to do it to make sure that it's working. And then we click to confirmation button to go to the next turn. So basically, now it's pinned, but make sure that it's not pinned when you play. So now it's unpinned and it's making the minimap smaller so we can see more screen and predict better. But when we want to predict, we will bring the mouse button to here. Okay, now it's expanding the minimap, and then to the x and y coordinate that the model wants to break, let's say, and clicking into it. And whenever it clicks into one predicted location, I'm clicking randomly now to here, then it will go to this self-confirm button. It will go into here and we'll click to guess, and it will guess the position. So this is more or less the logic that we have in here. Whenever we know the x and y coordinates, we do this movement with the mouse and we make it play. And in order to plot this minimap, if we want this function of here, let's define it here. So it takes the x and y coordinates optionally, and basically it does what we did before here in here. So it builds this minimap with the predicted position and the Hobart and Kodiak, so we can see if the game is properly taking the screenshot and if we still have the pixel coordinates calibrated. So if we move them up, we'll see that it's not calibrated. Okay, so these are all the methods that we need in the GeoGuessr bot, and this will work for a single player as we will do now, but it will also work for multiple players to develop this more complex logic to make multiple bots with different models to play. So now let's build another file that we'll call main single layer.py. Here we'll be importing these libraries, this one of here, the LangChain ones, and also the get chords that we define here in select regions, and the GeoBot from GeoGuessr that we just defined. So we'll start by defining here the play turn function, and this will be running in every turn. And in every turn, we'll be doing the screenshot of our game. Okay, so let's click next. So this region of here, we'll be doing the screenshot. We'll be passing this screenshot to base64 and also to the message. So we'll be creating this list of images that is a single image in base64 to create the message. And with this message of here that has the prompt instruction and the image, we'll be invoking the bot. Okay, so here we pass the bot, and we'll be using the model of this bot to invoke, so to send this message and get the response of the model. And we'll have here the location, the x and y coordinate location in our screen from the bot extract location from response, if you remember. So if this doesn't work and it returns a none, as we saw before, if it fails, we will return none. We'll try to invoke again the model of the bot, as we saw before, with the same message. So luckily, most of the times it works, and if it doesn't work once, it will work in the second try. So here we'll print again and we'll have the location. And if location is not known, so if it worked in the first time or the second time, we'll select this map location. And if it didn't work the second time, we'll print that we had an error, and we'll select this x1 and y1 position of the minimap to at least not block. So we'll be selecting the top left corner of the minimap to follow and not block the game. And this select map location, if we remember, it goes to the minimap, it clicks where it guessed, and it clicks this button of here. Then this part of here, if we press space with this, we go to the next turn. Okay, so this is the full turn logic. And we'll define here now the def main function that will be calling this as many times as the game lasts. We'll call this main function with the number of turns and the plot, if we want to plot or not the results. And this is the logic of the main loop. So we'll start by checking if we have the screen regions.yaml file. If we have it, it's okay, it will open it. And otherwise, if it's not in our folder, it will call this getCoords function of here, and it will need to calibrate our screen regions. But if you move any part of the screen or if you play another day, it's good to calibrate it anyway. Delete the screen regions.yaml to make it calibrate again. So it's nice if you calibrate this often, because if you move any part or the screen of the game and so, it won't work. Then here we get from the YAML save load, we have this dictionary with the screen regions, and we create our bot here as we saw before in the notebook. Now here screen regions is the dictionary, player 1, then the model will be the provider chat Anthropic in this case, but we can use chat OpenAI, Google Generative AI or Anthropic, and the Claude 3.5 Sonnet like this. So this is the model name, all of this. And if we use OpenAI, this is the GPT-4o model name, and this is the Gemini 1.5 Pro model name. So we instantiate our model here, and for every turn in turns that normally are 5, so you can see here 5 rounds. So for every one of these turns, we are printing the number of the turn, and we call the playTurner function that we just defined here, and this will be running for every turn. So now we only miss this part of here to call the main function. So let's save this, and we are ready to go. So let's do this small again. But we are in the round 3, so let's go to geoguessr.com to start a new game, and classic maps, NMPZ, and play again. Okay, so now let's open here a terminal, and I will move me here maybe, yeah. So in order to call the main single player.py, that is our entry point for our logic, let's do Python main single player.py. And okay, it's very important that we have our game calibrated, okay, and don't move the screen or the minimap or anything. And it's already, the game started in the round 1 like this, okay? So you have to have everything like this. You have to see the screen, okay? Your IDE cannot block your screen, or the terminal cannot be in top of your GeoGuessr game. And now you can press enter and run this. So now in theory, it should start like, okay, turn 1. Okay, so it ran already and it go to that place and it clicked. It's pretty fast, okay? So now the second part here, okay, so it was 800 kilometers away. So it's dangerous to move it now, but we can see here in plots. Okay, it's predicting, okay, 700. So here we can click minimap and check. So you can see that it's properly calibrated because the red dots are in the good position. Now it was closer. Okay, so this is Anthropic, and in my previous experiments, I think that Anthropic is worse than GPT-4o. So here in the image, we are seeing how it's operating every time. Now it was closer. Okay, so it finished the 5 rounds, and here we can see in the breakdown how it did. So it's not bad. We can see that more or less it predicted pretty closer every. This was the worst. So it mistaken Lithuania by Sweden, but the other ones were pretty good. Portugal. So it's working. Now let's try to use GPT-4o. So to change the model, we have to go to main single player.py, and here we have to put, for example, chat OpenAI to try the GPT-4o, and here the GPT-4o model. Now we save this and let's play again. Let's put the minimap image, so it will be overwritten now. If you leave here the minimap image open, you can track better how it's going, and the terminal here. So now we are prepared with the next round here, the next game. Let's go to the terminal and Python main single player.py again, enter. And now it's the turn of GPT-4o. So let's see how it does. First turn. Okay. 100 kilometers away. Maybe it was even closer, but we have our pixel calibration not perfect, so we introduced this error maybe. Okay, this time was not that good. And we can check here, we have in the terminal the latitude and longitude and the pixel coordinates, so we can debug that if it's wrong. So we can debug if anything is wrong. Okay, for turn, pretty close again, 190 kilometers away. And the last turn. And only 50 kilometers away from the position. So I think that in general, well, it had a single one that was pretty far, but the other ones, and in general, GPT-4o is better. Yeah, that island, it took it pretty wrong. Yeah, Hawaii and this Japan island. So normally GPT-4o does pretty well. And the same would work for Google. So this has been the simple example of how to build this AI bot that can play the GeoGuessr game, taking the images of the screenshots. But in the next video, we'll see how to put all together, so how to put the 3 bots together to compete again. So we'll try to put them for 20 games to play and then check with more and more results which is the best model playing to the GeoGuessr game that with a single image from Google Street View can detect what place it's in the map. I think that this example is pretty crazy because with a already trained model, so you don't have to train by yourself a deep learning computer vision model, so you have this out of the box for a very low cost, and from almost any image of any place, it can predict where is this place in the world. So if you learn how to do this kind of bot, I think that this is interesting because you will learn how to do other bots for other games. For example, the poker bot that we already built some months ago in another video, or any useful application that you find, and make sure that you don't use this for cheating because this is unfair and you can be banned from the platform. So make sure that you use this for good reasons. Finally, make sure to subscribe if you like this content and to check what is the best model because we will be making them compete in the next video. So give it a like and see you in the next video. Bye bye.